Hello, Science 10. Today we are going to do naming ionic and ionic compounds. This is the beginning of chapter 2.2. You are going to start on page 13, and you are going to need your table of periodic, your periodic table as well. Okay, let's get started then. We are using the rules that are put out that have been developed by the International Union of Pure and Applied Chemistry. That is IUPAC for short. And this is just so that everyone who is naming compounds will know what everyone is talking about, because we're all using the same rules. So before we get into naming ionic compounds, we first have to kind of think about what an ionic compound is. So yesterday when we were doing those ion diagrams, we were looking at positive and negative anions. So when atoms want to become stable, they will gain or lose electrons. So when they become positively charged, that is a cation. And when they become negatively charged, that is an anion. When that transfer of electrons happens, so when one gains and passes it off to another one, when one loses an electron and passes that electron to another one to gain, this is what we call an ionic bond. And an ionic bond is just an electrostatic attraction. So it just means the positive charge is attracted to the negative charge. So because that's happening, generally ionic compounds are made up of a metal cation or a polyatomic cation. We'll talk about those in a bit. And a nonmetal anion or polyatomic anion. When you read the formula for an ionic compound, it is telling you the simplest ratio that will result in the overall compound adding up to 0. So we want all of the positive charges to be equal to all of the negative charges. And that means we are now net 0. A net charge of 0. So, for example, when we write sodium chloride's formula, it becomes NaCl. Sometimes what you'll see is below or beside and kind of below the element, there will be a number, and that number will tell you how many of those ions we need. When you don't see a number, that means there's only one of them. So when sodium and chlorine want to bond to form sodium chloride, they are going to bond in what we call a 1-to-1 ratio. So 1 sodium ion will bond to 1 chloride ion. And so what happens is that we get what we call a crystal lattice. Because they're forming in these fixed intervals, we will end up getting a fixed lattice. And because sodium and chloride bond in a 1-to-1 ratio, we get what we call a cube formation. So if you were to ever take a big chunk of sodium chloride, or if you've gone out to Banff and you've been in the mineral shops, you will see big square blocks of halide, which is pretty much sodium chloride. It's a salt similar to it. And what you do is if you were to hit it, it would break apart, and it would continue to break into tinier and tinier cubes. It would hold its shape. Okay, so this is very important that we know how to read a chemical formula. So if I was to say barium chloride, so again, you're going to learn this later on, but we just need to read the formula first. BaCl2, you could then tell me the ratio would be 1 barium ion to 2 chloride ions. So no number means 1 for barium, The 2 next to the chlorine means 2 chloride ions. So this would be barium 2 chloride 1 negative to 2 chlorides. Whoops. Let me write that a little bit better. To 2 chloride negatives. And barium is 2 plus. Okay? So, when we are looking at naming ionic compounds, and we're going to look at the ones that only are univalent. So univalent, uni is 1 charge. So if you take a look at your polyatomic ions, you will see, sorry, not polyatomic, if you look at your periodic table, we are looking at the elements in group 1, group 2, group 3, because all of these have charges that are only 1 possibility. When we get into the transition metals, a lot of them are multivalent. So you'll see here, if we look at atomic number 22, titanium has 2 possible charges. Okay, so we're not going to do those right now. If we go over to the non-metal side, we're looking at group 15 mostly, 16, 17, and then 18 doesn't form. Okay, so univalent means it only has 1 possible charge. The polyatomic ions now are up here. And a polyatomic ion is a group of atoms that behave as 1. Okay, so if you look at hydroxide, which is very common, hydroxide is right there. That oxygen and hydrogen act as 1 compound. They're never, or 1 molecule. They're never going to be separated from each other. And the overall charge of that polyatomic is 1 negative. Okay, so let's keep going here. So when we name an ionic compound, step 1, we're going to name the metal or polyatomic cation. The only polyatomic cation that is positive, or that's, yes, positive, is ammonium. Okay, all the other polyatomics that we're going to be dealing with are all negative. The second thing you do, so the first is the name of the metal or polyatomic cation. And then the second step we do is we name the anion. The anion will always end in "ide," and sometimes we'll have a polyatomic anion, so then we will write whatever name it has. So take a look here in the polyatomics, look at some of those names. We have acetate, so 8 could be an ending. Borate, carbide, IDE, chlorite, ITE, sulfide oxide, or sorry, peroxide, silicate, okay, sulfate, so ATE endings, IDE endings, and yeah, okay. Okay, the key to finding a polyatomic ion in your compound is when you see more than 2 elements together. Okay, so how do we make this work? How do we get it done? When we look at the formula, we're going to start and read left to right. The cation always comes first. So this is magnesium, Mg. It's an ion, so we have to write the charge. Go to your periodic table, find magnesium, here it is. Its charge is 2 positive, so we're going to write that down. The magnesium ion is 2 plus. Then we're going to take a look at what comes next. We've got bromide. Okay, so bromide, if you take a look on your periodic table, go all the way over to group 17. Here's your bromide, number 35. Okay, so it's Br 1 negative. or negative. So now what we do is we just write the names out. So the cation is going to be magnesium. We don't use ion, we're just going to write magnesium. There's the cation, and then we write the anion, bromide. And that will be the ending of the compound, magnesium bromide. Okay, let's try it again. Read left to right. Na. Okay, I have 2 of those, but what is the charge? To find the charge, we go to the periodic table. Sodium has atomic number 11. So here it is here. There's sodium. It's in group 1, so its charge is 1 plus. Then we take a look at the ending. Oxygen, there's 1 of them. Oxygen, if you look at your periodic table over here, is 2 negative. So I'm going to write that in so that's atomic number 8. And we're going to write it here. O2 negative. So now I write sodium first, oxide second. There's my cation and then the anion. Okay, so let's pause the video here and give it a try and see if you can do the next 3. C, D, and E. Okay, so you're finished. Let's go over the answers. So, Ca, calcium, Ca2+. Cl, there's 2 of them, but each chloride ion has a 1 negative charge. This would be calcium chloride. Okay, next, K, potassium, K plus, 1 plus. S, sulfur, there's only 1 of them, but it has a 2 negative charge. Okay, there are 2 potassiums for every 1 sulfur. So this would be potassium sulfide. Ba is barium. There's 1 of them, but its charge is 2 plus, because remember we look for that charge on the periodic table. There's 1 sulfur. It is S2 negative. We have barium sulfide. Okay, 3 different ionic compounds, all dealing with univalent, so no multivalence. Okay, the next now we're going to add in those polyatomics. So always start left to right. The cation goes first, Na, and it's going to be a metal, right? So Na is sodium, Na. Look up the charge for sodium on your table. Na plus. Now, take a look at this. I have more than 1 non-metal, NO3. That tells me it's got to be a polyatomic. So, we go to our data sheet and we look at the ones on the top here. It was NO3, I believe, yeah. So look in alphabetical order. Here is, oops. We don't want to do that. Here is NO3 nitrate, and it's NO3 negative. So we'll go on over here. And this now becomes NO3 negative. And now we just write their names. Sodium nitrate. Okay, so again, cation goes first, anion goes second. Okay, next one. Calcium is the cation. Ca, find it on the periodic table, 2+. Carbonate has two nonmetals, so that's how you kind of know you're dealing with a polyatomic. CO3. Whoops. So CO3, if you look it up on the periodic table, is 2 negative. So calcium carbonate. You think you know what you're doing, move at your own pace. I'll do one more example, and then I'll have you guys do the other ones on your own. So first element is K, potassium, K+. Looking at the next, we have more than one nonmetal, so it's a polyatomic. So go look it up on your table. MnO4 negative is permanganate. So this would be potassium permanganate. Cation first, anion second. Okay, try D, E, F, and G on your own, and then we'll come back and give you answers in a second. So the answers are Li positive, OH negative, lithium hydroxide. Aluminum, Al3+, sulfate, SO4 2 negative, aluminum sulfate. Ooh, this one's a little bit trickier. We have a polyatomic. This is the only positive one we have. That is ammonium. And then chloride, Cl negative. So now this is ammonium chloride. Last one, again, we've got ammonium now. And you'll notice ammonium in this case is bracketed with a 3. That 3 is telling you that you need 3 of those NH4s. Okay? So this is NH4+, PO4 3 negative. So you should have ammonium phosphate. Okay, I'm going to pause the video here. I'm actually going to stop the video here, and I'll put on a second part in a second here. What I want you to try to do is I'd like you to try to answer workbook page A16, number 2. Just name them for right now. Okay, give those a try. And you can also do textbook page 44, number 2. Let's do those, and then we'll come back with a second video.